I'm Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this video, we'll discuss difficult questions from previous test papers. Here are 4 questions for you. You can always pause the video, answer these questions, and then look into my suggestions. These questions are based on two formulae. One of them is sum of cubes, that is a cube plus b cube. As you know, this can be factored as a plus b times a square minus ab plus b square. And this formula for the negative values means a cube minus b cube can be written as a minus b times a square plus ab plus b square. Now, if you use this formula, sum of cubes and difference of cubes, you can actually solve all the 4 questions. We can say we're trying to factor the polynomials using the formula of sum of cubes and difference of cubes is their application. In case you want to learn from me, you can always send an email on the address given and explore our website for new updates. Now let's look into the solution of the very first question, which is sketch the graph of x cubed minus 9x squared plus 27x minus 27. How are you going to do this? Well, once again, as I was saying, we're going to focus on this polynomial quiz with difference of cubes and sum of cubes. So this will involve factoring applications. Graph of a polynomial is the very first one. We might derive a formula for a situation given here. Now let's begin with the solution of the very first question. Sketch the graph of x cubed minus 9x squared plus 27x minus 27. To sketch this graph, we need to factor the equation, right? So the idea here is to factor. If you factor, it'll be very easy to sketch the graph. Question given to us is x cubed minus 9x squared plus 27x minus 27. Now, to sketch this, we see that x cubed is given to us and 27 is cube of 3. They can be combined. That's the whole idea. First thing is to identify how do we factor. So if we combine these two, group them, then see what happens. We can write this expression as x cubed minus 27 minus 9x squared plus 27x. So here we have x cubed minus 3 cubed. We can apply the formula. And here 9x is common. And that gives you x minus 3. So do you see that x minus 3, which is developing as a common factor? That is what you need to identify in such questions. So, expanding x cubed minus 3 cubed, using the formula which we have learned, we have x minus 3 times x squared plus product of 3 and x plus 3 squared, which is 9, minus 9x times x minus 3. Now, x minus 3 is common, and we get x squared plus 3x plus 9 from the first factor and minus 9x from the other factor. This can be written as x minus 3, and here x squared 3x minus 9x gives us minus 6x and plus 3. 9 is 3 squared. So we could now write this as, let me write it on this side, as x minus 3 times what? Well, that is the perfect square, correct? This can be written as x minus 3 whole square. So you basically get x minus 3 whole cube. Now that is easy to sketch. It's a cubic function which is translated 3 units to the right. And therefore, we can sketch it as, if I put x as 0, we have 3, right? So if putting x as 0, we have 3. So we have a point which is x is equal to 0, y is equal to minus 3 cube as minus 3, and at x equals to 0, 3, we have 0, right? So x equals to 3, we have y equals to 0. So these two become a critical point to sketch. So at minus 3, we have the y-intercept, and so the graph, which has 0 as 3, can be now sketched as a cubic function shown here. Is that clear to you? So that is minus 3, and this is 3 for us. So that becomes the graph of this particular function. Perfect. Here is the typed out solution for you. So basically, we rearrange this particular equation taking minus 27 with x cube, which is x cube minus 3 cube. On the other two, we group them to take minus 9x together, expanding. We have x minus 3 as a common factor, and ultimately, we factored this as x minus 3 whole cube, and that gave us the graph, which is translated on the right hand side, and the x-intercept being at 3, the y-intercept will be at minus 3, which is not shown in this particular graph. We can extend and get this, right? So we know when x equals to 0, y equals to minus 3, so that will be the y-intercept. Perfect? Now let's look into the second question, which is we need to factor m to the power of 4 plus 15m cubed plus 75m squared plus 125m. Well, m is common. That is first thing we could, of course, do. Now again, 125 is 5 cubed. And therefore, we can actually use difference of cubes once again. So let's rewrite this question, which is m to the power of 4 plus 15m cubed plus 75m squared plus 125m. M is common, so that's factored first. We have m cubed plus 15m squared plus 75m plus 125. 125 is 5 cubed, and we see all others are also multiples of 5. So that helps us to identify that this could be an application where we could use a cube plus b cube formula. So we are rearranging, as you can see now. Perfect? So this rearrangement helps us to use the formula a cube plus b cube. M times m cube plus 5 cube, right? So it could be written as m plus 5 times m squared minus 5m plus 5 squared. The other factor we can take 15m common, and what we get here is m plus 5. Now m plus 5 is a common factor. So we get m squared minus 5m plus 25 plus 15m. Now that gives us m times m plus 5, and here we have m squared minus 5m and 15m can be written as plus 10m plus 25. Now this part is also a perfect square, m plus 5 whole square. So we get m times m plus 5 times m plus 5 whole square. So we have this as equal to m times m plus 5 whole cube. You get the idea. So that is how we can actually factor. So this quartic equation is combination of these two zeros. Now this can be sketched very easily. We have the y-intercept, which is 0 itself. X-intercept is also 0. And if I put m equals to minus 5, then we get another 0. So we have two zeros. Since the equation is quartic and leading coefficient is positive, the right side is up and both face the same side. We have a cubic root at minus 5, so which will be kind of like this. And now we can actually combine and sketch the graph. You see that. So that is how the function can be sketched. Now let's see the solution. Here is the solution for you typed out. So basically what we did was we brought the terms 125m and m to the power of 4 together. Initially, of course, we factored m, and these two terms will form a cube plus b cube. So applying the formula of a cube plus b cube this time, which can be factored as a plus b times a square minus ab plus b square, helped us to factor. And so we can now get the graph as shown here. You get the idea, right? So that is how you could sketch the graph. So after factoring, you may try to sketch the graph also. I hope the solution is absolutely clear. Now let's look into question number 3. Now this is a very important question from test point of view. I would like you to pause the video and answer this question. X cubed plus 3x squared minus 9x plus k. K has two identical linear factors. Prove that the value of k is either 5 or minus 27. So that's the question for you. Important term to understand is two identical linear factors. What does that mean? Let me explain you that. So we have x cubed plus 3x squared minus 9x plus k. Identical factor really means that if I have one factor as x minus a, the other one is also x minus a. Now it's a cubic equation. It can have maximum 3 factors. So the second factor is x minus a, third will be something different, x minus b. So that is what we get. If you multiply this and compare the coefficients, you can find what k is. That is the strategy. So basically, you could write this as equal to, you can product this x minus a into x minus a whole square means what? This is x squared minus 2ax plus a squared multiplied by x minus b. And when you open this up, you get 6 terms, and these terms are x cubed minus x squared b multiplying with minus 2ax, we get minus 2ax squared, and with b we get plus 2abx, and with a squared we get plus a squared x, and we get minus a squared b. So these are the terms which you get. Now you can combine some of the like terms. We have one term with x cubed, perfect. And then with x squared, what do you notice? Well, the term with x squares are being highlighted. So these are the two terms with x squared. Let me rewrite these terms as minus b and minus 2a. So let me take minus b and minus 2a, correct? So these are with x squared. Now, let us rewrite the terms which are with x. So the two terms with x are 2ab and a squared. So we can say plus 2ab plus a square. These are the terms with x. And then we have the constant term, which is minus a square b. Do you see that? So we combine these terms. Once we do that and we compare this with our original equation, then what do we get? What I'm trying to say here is that 3 should be equal to the coefficient of x squared. So we get one term which is 3 is equal to minus b minus 2a. Now that can relate b with a, correct? So we can write b equals to what? So b is equal to minus 3 minus 2a. Perfect. So that is one equation for you. The second equation to look into is comparing the coefficients of x, which is 9 with a negative sign. So negative 9 is equal to 2ab plus a square. Now in this term, if I substitute what b is, I can solve for a. You get the idea. So in this equation, I will get minus 9 equals to 2a, and b is minus 3 minus 2a plus a square. So you can actually find the value of a. It is a quadratic equation. We have minus 9 equals to minus 6a, and that becomes minus 4a square plus a square. Bringing all these terms to the left hand side, minus 4a square plus a square gives you minus 3a square. So that gives you 3a square here. And 6a becomes plus 6a minus 9. So equal to 0. Now that is, you can take 3 common, right? So this is equals to 3 times a square plus 2 times a minus 3. And this can be factored. Perfect. So you get two values of a. Minus 3 really means minus 3 times 1. And therefore, I could write this as 3 times. Let me just push this page a bit and then write the final equation here. Okay. So what I'm going to do here is write this as equal to, we have, let me rewrite it here, equals to 3 times a minus 1 times a minus 3. That is how we can factor this, right? So, sorry, plus 3, right? So we have plus 2a. So that implies that 0 equals to this, and this gives you a as two values. What is 1 and the other one is minus 3. For these two values of a, we will get two different values of b also. Do you see that? So we have two values of a, we can now write two values of b. So if a equals to 1, then b is equal to what? So if a is equal to 1, in that case, what is b equals to? Substitute 1 here for a. We get minus 3 minus 2 times 1, and that is minus 5. And as far as minus 3 is concerned, then in that case, b is equals to minus 3 times 2 times minus 3. And that gives us, this is minus 6, and minus 6 minus 3 plus 6, right? So minus 3 plus 6 gives you 3 value. So we have two sets of values of a and b. And we need to find what? We need to find what k is, correct? So k you can find by comparing the constant terms, which is in the equation given as k, and here, which is product of a square b. So k basically is equal to minus a square b. Now for both these terms, we can actually multiply a and b and get our answer. Is that clear to you? Right? So if we do these two, we'll get both the answers. I'd like you to verify this. Perfect. Here is the solution, exactly what we did. So we have this equation, x squared plus 3x squared minus 9x plus k. Since we know that it has two identical roots, we have taken that root at a. So x minus a whole square becomes the first factor, x minus b is the other factor. Expanding and simplifying, and then from here getting the three equations, comparing b plus 2a with 3 negative sign and 2a plus a square with minus 9, and then we know the constant term is minus a square b. We actually get all the three equations which we discussed. Elimination helps us to find the value of a and get the value of a as 1 or minus 3. If a is 1, b is minus 5, and if a is equal to minus 3, then b is 3. And for these two values, we know the value of k is basically equal to what? The k is the constant term, which in our case was equal to minus a square b. So we substituted the values of a and b. So if the value of a and b is, let's say we have one of them here, that if a is 1, then b is minus 5. And the other set is when a is minus 3, then b is 3. Substituting these two sets, we get two different answers. Minus a square b is basically equal to minus a is 1 and b is minus 5. Multiplying, we get plus 5, verifying that k could be 5. In the other set, minus a square b, substituting minus 3 for a and 3 for b, we get minus 27, so we get the other answer. So I hope this is absolutely clear. Have a good look at it. This question has appeared many times in the test paper, and I hope its solution will help you. So I hope this solution is absolutely clear. Let's move on and take the last example. Now this question is another very important question from test point of view. The question is, a cone is inscribed in a sphere of radius 2 centimeters. Determine volume of the cone in terms of x, that is v of x, in factored form. Write the domain of the function. So it has two parts. We have to write domain and we have to find the function in factored form. We're given a sphere with inscribed cone. The radius of the sphere being 2, that means all these sides are also 2. X, the value, is basically from C to the center of the cone base, right? Now, what is the volume of a cone? Volume of a cone is 1 by 3 pi r square h. That means we have to find what height is and what radius is. Now, to find the value of r, we can look into the right angle triangle shown here, correct? So in this right angle triangle, let me redraw this triangle. We have 2 as the hypotenuse, x as one of the side, so this is the radius. Now this can be found as 2 square minus x square square root. So I can write this as 2 square minus x square square root. So that is how you get the value of r. As far as height is concerned, which is from E to D, so height is E to D, and that is 2 plus x. So we have all the terms in terms of x, and therefore we can now write the volume as equal to 1 over 3 pi square of square root of 2 square minus x square whole square, and the height, which is 2 plus x. So that gives you 1 by 3 pi, and that is 4 minus x square, and this is 2 plus x. So we have it in the factored form. Well, 4 minus x square can be written as 1 by 3 pi 2 plus x times 2 minus x and times 2 plus x. So in the factored form, I could simplify and write this as 1 by 3 pi 2 plus x whole square times 2 minus x. So that is how we actually get our expression. So that is the factored form of the volume. Now the idea here is that how do we find the domain of this function? So I like you to think over it. How do you find the domain? Well, you know the volume it is non-negative, right? So the volume is non-negative. That is to say that this volume has to be greater than 0. To make it greater than 0, the factor shown here, which is 4 minus x squared, should be positive, and that will lead to the domain. So if you write 4 minus x squared greater than 0, you do get your solution, correct? So that means that 4 is greater than x squared, and square rooting will mean that 2 is greater than square root of x squared, which is absolute value of x, correct? So that means x is between minus 2 and plus 2. Now see, the most important part here is that in the domain, we are getting this dimension x as negative. Is that possible? Is that possible? That is a very important question to answer. Well, interpretation is that height is taken as 2 plus x, right? So look at this. Height is 2 plus x. If x is negative, in that case it will be 2 minus x. 2 minus x means we have a cone which will be like this. So let me just redraw the cone. If x is negative, then we'll have a cone which will be kind of like this. Do you see that? So in that case, the height will be 2 minus x. And that is the interpretation for x being negative. So this could be a very important part of question also. Here is my solution. Have a good look at it. And I hope that helps you to understand this situation. Very important question. So we have actually discussed 4 most important questions based on polynomial factoring where difference of cubes or sum of cubes is involved. I hope that really helps. If you like and subscribe to my videos, that would be great. And if you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.